Hi everyone. Today we look at object-oriented programming, and what we're going to learn is what classes are, how we define classes, how we use them, and there's a brief discussion at the end um, on references and values, and passing by reference versus passing by value. So, object-oriented programming is based on the idea of looking at problems in terms of how things can be represented as objects, and then how their properties can be described, and how the solutions to the problems can be built around the use of those objects. So an object can be anything. It can be a student or a desk, a circle, anything. And you as a programmer decide what constitutes an object and exactly how you describe that object. So an object is going to have a unique identity, state, and behaviors. The state of the object consists of the set of variables that you assign to that object. So the simplest way that you can describe an object is it's a set of variables called data fields or properties or attributes. All of these are used synonymously, along with a bunch of methods that you can use to manipulate those data fields or variables. The set of methods that you implement for your objects represent the behavior of that object. And here's a visual representation of how the creation of an object can work. So we've got a class here called dog. Um, the class is the data type of the object. So whenever we are ready to represent our objects in our programs, we're going to be implementing them as classes. And every time we need to use one of those objects, we'll be instantiating the class. To instantiate the class means to create an object that is of that data type. So here we got a class called dog, and here are the two sets that we just mentioned on the previous slide. The first set of data fields, or the variables associated with the class. In this case, we're trying to describe what a dog is, so we're using fields like breed, size, color, and age. And the methods that we use to manipulate those fields are eat, run, sleep, and name. Now, how do you make a decision about what fields exactly to include and what methods to include? Well, that is entirely up to you. So the programmer decides how to represent a certain class, what kinds of fields need to be created, what kinds of methods need to be created, and how to use that class in programming. So assuming that this is a good definition for the dog class, we can use it to instantiate three objects off of it. So we got a dog1 object, which happens to be initialized as a bulldog. Doesn't quite look like a bulldog, but still. The size set to large, the color light gray, the age 5 years. We got a second object here that has been instantiated as a beagle of size large, color orange, 6 years old. And finally, the third object is a German Shepherd, again large, white and orange, 6 years old. Okay, so this is just a visual example of how instantiating works. We got the class over here. We create several objects, in this case 3 objects, based on that class. Very much like declaring variables. If this was int, these would be 3 integers. Except that now we're not working with primitive data types, we're working with an advanced data type. What kind of data type? Well, that's up to you, the programmer. So the class allows you to create advanced data types, and you decide what exactly goes into that data type and how it's implemented. Another quick example here of an employee class. So whoever designed this thought that it may be pertinent or prudent to include the following attributes: social security number, gender, and date of birth. That's how an employee is described. Now the methods that, or the behaviors, or the methods that they use to manipulate those attributes, in this case, are called get social security number, get gender, and get date of birth. Okay, so maybe it's not an exhaustive list, so maybe they're just getting started on this class, but this is a good snapshot of what your class definition could look like for an employee, for example. The idea with classes and objects is that you're really describing objects that are of the same data type. So, for example, here on this slide, you got a whole bunch of light bulbs. Although they look slightly different, they're essentially one and the same thing. They're light bulbs. So they lend themselves nicely to being implemented as a single class in a program called light bulb, for example. The general form of a class, so you can see the syntax here. We use the keyword class, come up with a good name for it. We use valid identifiers here, and hopefully something that is descriptive. And then you got a set of instance variables. These are your attributes. You decide what types they need to be and what they're called, and then you declare the methods. Okay, again, you decide what types there should be and how they're implemented. Now, do you have to have both of these? The answer is no. It's really up to you to decide whether you include any variables at all or any methods at all. But as a rule of thumb, if you want your class to be useful, usually you strive to describe it as in much detail as possible, and so usually you're going to have a bunch of these along with a whole bunch of those as well. And we're going to see some examples. We'll start using these in our programming too, and you'll see how this works exactly. Also, you are strongly advised to have your variables declared first, and then you list all of your methods or define all of your methods. So we do use variables for the data fields and methods for the behaviors. Remember that these are going to be used synonymously from now on. The types of methods, we are going to have something called constructors. In Java, they will allow you to set up your objects. So once you have defined your class, the constructors are the methods that actually instantiate the class. Every time you need a new object, which is of type of a certain class, you're going to be calling one of the provided constructors to construct or build that object. A class definition, well, this is a more specific example than the one from the previous slide, and like I mentioned, it could contain just methods or variables. It's entirely up to you. You decide what is useful in with respect to the kind of problem you're trying to solve. Okay, in this example we got a class called circle. We do have one attribute called radius of type double, which has been pre-initialized to the value of 1. We do have a couple of constructors. Constructors are going to be methods that are named exactly the same way as your class and that do not have any kind of return data type, not even void. That's how you can tell constructors from the rest of the methods. You can have multiple constructors setting up the objects in different manners. Like, for example, in this case we got one that doesn't take any arguments and doesn't really do anything. It's there just so that if you try to construct the object without passing along any arguments, the program doesn't crash and you still get to create the object, but you don't initialize anything. The reason why they still make sense here in this particular example is that radius has been pre-initialized to 1. Okay, I wouldn't do this in this exact way. I would personally always set up the attribute inside the constructor, but whoever designed this thought that this would work for them well, and it does. It's valid syntax. So you can construct a new circle, and if you don't provide any value for the radius, then it's going to get a value of 1. If you do provide a value for the radius, however, this is what Java is going to use to set the value of that radius attribute. In addition to the two constructors, we have 3 different methods. One is called getArea, which calculates the area of a circle with whatever the radius is. We got a getPerimeter, which calculates the perimeter, And finally, we got a set radius, the job of which is to change the value of the radius attribute if you need to do that. The creation of the object. Quite like with the strings, it happens with the new keyword. So over here we instantiate the circle class by creating a couple of objects called C1 and C2, and we create them with the help of the new keyword. So this is going to set aside enough memory to store one circle object, and it will also initialize that circle object. Now, since we are providing a value of 1 here for the constructor, this is the one constructor that's going to get called to create that C1 circle, and the radius isn't really going to change because the default value is 1. However, we're still going to call this constructor, and we're going to set up the circle using this one constructor. If you execute this part of the code, you should get the area for a circle with a radius of 1. Likewise, down here, if you execute this part of the code, you should get the area for a circle with a radius of 5. And these are the two constructors that we saw earlier. As I just mentioned, they should have the same name as that of the class. They should not have any return data type, which means not even void, and that you invoke them using the new keyword whenever you create a new object. A constructor that doesn't have any parameters is sometimes referred to as a no argument constructor. If you don't provide one of these, Java is going to set up one for you automatically. So the general format for the constructors, new and then the name of the class. A class may be defined without any constructors. In that case, as I mentioned, Java will actually set up on the fly a no argument constructor for you that doesn't do really anything to the attributes at all. It really just allows you to create a new object and not crash the program, even though you don't have any specifically defined constructors. Declaring object reference variables. Okay, what that says in simple English is that once you have your class, you're now ready to start instantiating it and creating new objects. So once I have my circle class, I can create a new object called, for example, my circle, just like I declare any other variable. If this was an integer, I would do int space and the name of my integer variable. Now, since this is a circle, I'm going to do circle space and the name of my circle. This wouldn't make any sense to Java at all if the circle class does not exist or if it's not accessible. But assuming that it exists and I have defined it, then this is just like declaring any other variable as far as Java is concerned. Declaring and creating the object in one step, we've seen that before. You declare your my circle, and at the same time you also initialize it. In this case with the default constructor that takes no arguments, whereas down here the C circle is constructed with the second constructor, and it's going to get a radius of 12.5. Alright, now we get to accessing the object's data and methods. The way we do that, we have actually done it, for example, with the math power function and quite a few other functions available with the class, the math class. We use the dot or the dot operator to access individual data fields or methods within a class. Okay, an example of that, assuming we got a circle called myCircle, to access the radius, you do myCircle.radius. To access the getArea method, you do myCircle.getArea, and since this is a method, you also need to include the parentheses. Okay, a word of caution here. So far we have always been using the so-called static methods. As I may have mentioned in class, the static keyword identifies the method as one that you want to be able to call without creating any objects. So it belongs to the class, such as in this case here, the POW method. You want to be able to call that without creating a math object first. And it works. From now on, when we create our own classes, um, nearly all methods are not going to be static, and what that means is that, for example, if you try to call the get area method on the circle class, that won't work because you're trying to get the area of the circle data type, and that makes no sense at all. You have to have an actual circle for which you want to get the area. Okay, so you can only invoke the get area method on a particular object, and those are dynamic methods. They really depend on the objects in order to work. Alright, the data fields can be of reference types. For example, such as in this example here, the class student has one data field called name, which happens to be a string. Okay, strings are references to memory locations, and when you instantiate the student class, this is likely going to be initialized to null if you haven't set the name of the student. Okay. Oh, we haven't seen this before. Alright, so the null value, as far as references go, is the same thing as a 0 as far as integers go, or false as far as booleans go. Okay, so it really is a way for you to define the value to no location in memory, to nothing. Okay, so the value is no longer this variable, like the name variable here is no longer undefined. However, it's not pointing anywhere. So that's kind of like assigning a 0 to an integer or false to a boolean. You've initialized it, but it's not really pointing anywhere just yet. You don't get automatically default values to your local variables inside methods, which means if you declare an integer or string, for example, inside a method, before using them, you also want to take care to initialize them to something. If you attempt to use them right away, the compiler is going to produce an error like this one here. It's going to say your variable might not have been initialized. Variables of primitive data types versus reference types. Well, with the primitive data types, you actually store the value in memory. With a reference data type, you store a reference to a memory location, and that memory location has the value or the list of values, whatever the case might be. With the primitive data types, let's say we got I and j as two integer variables, assign the values of 1 and 2. When you assign the value of j to the value of I, you just copy the actual value into that second memory location. So now both I and j are going to be equal to 2. With reference data types or object data types, as is the case today, it doesn't work that way. Okay, look at this example here. We got two circles, C1 and C2. They've been initialized and they point to these two references point to two different locations in memory. So if you set C1 to get the value of C2, you're not copying the data from C2 into the fields of C1. You're really just adjusting that reference pointer to point to the same memory location. So C1 is now pointing to the memory location where C2 is pointing. The part of memory that was reserved for C1 now becomes what they call in Java garbage, and the Java virtual machine is smart enough to handle garbage on its own. Other programming languages may require you to explicitly free up the memory, or you might have problems. Explicitly freeing up memory here can be done as well. You can set a pointer to this location to null, and this is a way for you to tell Java that you're no longer going to be using this memory. But even that isn't necessary. The Java virtual machine, when you run your program, when you compile it, it's smart enough to figure out that this part of memory is no longer going to be used, and it will properly dispose of it, or it will free it up in the right way. Okay, and that's what they say here on the next slide. So once part of memory is no longer used, it's garbage, and it's going to be collected by the Java Virtual Machine. Now that takes us to a brief discussion on a couple of predefined classes. The main purpose of this is to draw your attention to the fact that there's quite a few classes out there, or even class libraries that you can use, and you don't have to reinvent the wheel every single time you start programming. For example, the date class can help you work with the time and date. It's got its own method that can convert the date to string, and in this example here, they're actually referencing the class using the package name as well. You don't have to do this if you import java.util.date at the beginning of your program. Or in fact, if you just do import java.util.star, you're going to get all the utilities all at once, and you can just do date space date here. And then when you call the constructor, you just call date with the parentheses. All of that becomes redundant. It's no longer necessary. It does pay for you to explore these predefined classes further and see what they can do for you. In the case of date, you can construct a date object using the current time, or you can construct one using the time that has elapsed since January 1st, 1970. You can convert that time to a string. You can convert the number of milliseconds for that time since 1970, January 1st. And there's a few other methods that you can use as well. Random class, likewise, we've used random so far quite sparingly. We may actually need to come back to it and use it more often. Random allows you to use the current time as its seed. This is the only way we've used it in class so far. You can seed your random object with a specified seed, and then you can ask for a random value based on that seed. What kind of value? It can be an integer, long, double, float, or even boolean. Okay. If two random objects have the same seed, they will generate identical sequences of numbers. And here's an example of using class random. You're asking for random integers in the range 0 to 999. However, look at this. Both of these random objects, random1 and random2, have been initialized with the random seed 3. So what ends up happening, what you should see on the screen, is a sequence of, well, seemingly random numbers, but an identical sequence for both of these objects. And that's the way that it works with the random class. Instance variables and methods. We continue looking at how accessing data fields and methods work by looking at the static modifier. Okay, so the static modifier allows you to create static fields. They are shared by all instances of the class, which means all objects that you create. They're not tied to any one specific object, and static constants, if you want to use those, are always going to be final variables by all the instances of the class, so you're not going to be changing those. Okay, using instances and static class variables and methods. Let's take a look at this example here. This class is called circle with static members. It's got a radius variable. It's got a static number of objects. So this radius is going to be specific to each object that you create. It's dynamically created. The static one down here, the number of objects, is one single variable for the entire class or the entire data type. So whenever you increment that number of objects, you can keep track of how many objects you have created. It's going to be an accurate number because it's only one single variable in the entire class. It's not a separate variable for each object. Okay. Here are the two constructors. If you set up a new circle with static members with a radius of 1, you increment the counter. Likewise for the other one, if you provide the radians, you use that for your radius and you increment the counter. Anytime you query or you look up that value, it's going to tell you exactly how many objects have been created from that class. So this is one way that static variables can be useful. Okay, an instance method can invoke an instance or a static method. Actually, a better way of understanding this is on the next slide. Here's how it visually works. Your dynamic methods or instance methods, the ones that are linked to your objects, can access everything. It can access all other instance methods or data fields, and it can access or invoke all other static methods or data fields. However, if you got a static method, one of those that are defined for the class and not for the objects, you can still invoke other static methods or access other static fields, but you cannot access any instance data fields or invoke any instance methods from that method. And it makes sense. The visibility modifiers, public, private, and protected. If you define something as public, it will be accessible from anywhere. So it will be visible to any class in any package. If you define something as private, the data or methods can be accessed only within that same class. No other class can access these methods or data fields. If you define something as protected, it's going to be accessible only by the declaring class and its subclasses. Inheritance is not the topic for today. We'll actually cover this next week. So suffice it to say, when you create a new class, you can derive other classes from it. So just think of it that way. And the protected keyword in English says, okay, this one item should be available to my class and all other classes that I'm creating based on this one. Package private or package access. Now this is something you probably haven't seen in other high-level languages. So if you don't use any specific modifier, okay, if you just leave that field blank, then you're setting the visibility to package level, which means the classes, methods, and data are only accessible by all the other classes from within the same package. And on the next couple of slides, you're going to see some examples of these. The first two programs are part of package 1. The first two classes are part of package 1. The third one is part of another package, package 2. So in here we got a class called C1 with a bunch of attributes and methods. We have a public variable X. We have package level variable Y. We have a private Z, and similarly we have the same thing with 3 different methods. Now over here in the second file for class C2, we are creating objects instantiated from the C1 class. After we do that, we should understand that within the C2 class we will be able to access X and Y from C1. Okay, we won't be able to access Z because that one has a modifier of private. Only this class can use it. And we can invoke methods M1 and M2, but not M3 because that one's private. Now in C3, which is a different package, we can only access the public field and the public method, X and M1. And we won't be allowed to access Y and Z from the data fields, or M1 and M3 from the methods. A non-public class has package access by default. Okay, and this is an example of that. So over here we got a public class called C with a private data field. Inside the main method we print X, and we access the convert method of that class, okay, which is also private. So we can access both of these, so this is okay because we're using it inside class C. In the second example, public class test, we're trying to access the same two items, the data field called X and the method called convert. That will fail because they're both defined as private and are not accessible in this class test. You're not really forced to declare your data fields as private, but you're strongly encouraged to do so because of this thing called encapsulation, one of the 4 fundamental principles of object-oriented programming. It has to do with hiding information, so not letting other classes just arbitrarily see and access data fields is something that is considered to be one of the really big assets of object-oriented programming, and the term to describe that is called encapsulation. Okay. You're protecting your data from accidental changes, and you're making your code easier to maintain and less error prone. So for example, with the circle class that we tinkered with earlier, we don't really want to allow someone to set a negative radius, okay, and so long as radius is private they won't be able to. We control how the value of radius is going to get changed. Accessors and mutators, a little bit of terminology here. To retrieve or update a private member, fields of a class can use, again, this is something that's not provided by default. It's entirely up to you to ensure that these exist and how they're implemented. Methods that let you view the value of a private member of a private data field are generally called get methods or getters or accessors. These are all synonymously used. If the return data type has to be Boolean, you would name it is and then the property name. If it doesn't have to be Boolean, then you would name it get and then the property name. If you see something like that, then you're looking at a getter or an accessor. For the setters or set methods or mutators, they use set with the property name. Okay, so if you see these terms, mutators, these are methods that let you change the private data fields. Accessors are methods that let you view the current state of a data field. Passing objects to methods. It's important to know that this is perfectly legal. So primitive data types are passed by value. We already know that. Reference data types, such as objects, are also passed by value, which value happens to be the reference itself. But don't forget that that is a reference. What that means is it's pointing somewhere in memory. So in this example here, we're passing 2 arguments. One is an integer, a value of 5, and the other one is a circle, which is we pass along just a reference to that circle. It's located somewhere in memory. So now the local method can use the 5 but cannot change n. However, the local circle C happens to be a reference to the same memory location where the outside circle is pointing. So don't ever forget that, because you may inadvertently end up with unpredictable results. Arrays of objects, perfectly legal as well. You can have arrays of strings. We've used that previously. Now we look at arrays of objects. You use the data type or your class name in this case along with the square brackets, and then you come up with the name for that array. So now invoking, for example, a getter like getArea on the circle array actually involves 2 different levels of referencing. One of them is going to circle array references the entire array, and then circle array 1 references the second circle in the list, right? Because the first circle is going to be circle array 0. And here is a visual representation of the way you access objects within an array. So circle array is a reference to a list of references, each one of which in this case is going to take you to an individual circle that has been stored somewhere else in memory. Nothing special. We've already used arrays of strings. This is conceptually it's still the same thing. Okay, and that wraps up our introduction to object-oriented programming, classes, and objects. Thank you very much for watching.